On average, a person scratches about 97 times a day. It feels automatic, almost unconscious. But under the microscope of neurobiology, every scratch is a pre-programmed ritual of violence. When your fingertips rake across your skin, millions of nerve cells erupt into signals, and your brain, instead of stopping you, actually encourages the act. It convinces you that a small dose of pain will relieve the discomfort. But in reality, you are participating in a deliberate loop of self-destruction, injuring yourself to temporarily fool a nervous system that is glitching. Why would evolution preserve this mechanism of mild torture? Because itch pruritus is a survival code embedded deep in the human brain. It is not a weaker version of pain. It is an independent signal, a separate alarm designed to awaken your defensive instincts against microscopic threats. Every time you scratch, you are not merely reacting to an itchy spot, you are operating a biological radar system shaped by millions of years of natural selection. Human skin, averaging about 2 square meters, is not just a mechanical shield, it is a dense neural map, where countless sensors function like radar stations guarding the border of the body. Specialized sensory nerve cells known as C-fibers are scattered throughout the epidermis, tasked with detecting the smallest disturbances, a stray hair, a fungal spore, or microscopic insect toxins. When these fibers detect a foreign intruder, they fire electrical impulses, sending signals through the spinal cord to the thalamus, the brain's relay hub, where the message is decoded into itch. But itch does not demand that you run the way pain does. It issues a different command: remove it. It pushes you to locate and destroy the threat on the spot. Scratching, therefore, is a defensive reflex. The sophistication lies in the separation mechanism. Pain and itch do not share the same pathway. While pain can travel quickly through A-delta fibers' fast-conducting nerves, itch runs through a distinct route slower, steadier, and persistent. This is evidence that the body maintains two independent warning systems, one for major damage and one for subtle invasion. If you imagine the body as a nation, then skin is the border zone, and itch is the siren for microscopic incursions. It compels action before an invisible enemy can penetrate deeper. A preventive strategy that no lower animal possesses in the same way. For thousands of years, medicine treated itch as merely a weaker version of pain. Aristotle once described it as, "Itch is a small pain, not strong enough to make a person scream." That belief persisted well into the 20th century. Then, in 2007, an experiment at the University of Washington shook. Neuroscience researchers discovered a specialized group of neurons that transmit itch signals, only completely separate from the pain network. They called them pruriceptors, neurons that respond specifically to histamine and other itch-inducing substances, such as chloroquine or bile acids. When activated, they send electrical pulses up to the brain along a private line, never overlapping with pain-transmitting neurons. Medicine was forced to redraw the entire sensory map. This discovery was not only scientifically important, it was profoundly human. Millions of patients with chronic itch, from eczema to liver disease, had been dismissed as psychologically sensitive. In reality, they were victims of an overactive neural transmission system. From that point on, itch was no longer mild pain, but an independent signal that the brain prioritizes as an environmental warning. In evolutionary terms, this means a small mosquito bite could save you from malaria if you respond at the right time. Itch, then, is proof that the body does not seek comfort. It seeks information. It does not exist to make you suffer. It exists to keep you alive. One of the biggest paradoxes in neuroscience is this: powerful painkillers like morphine can trigger intense itching. That is because the pain system and the itch system function as opposing forces. When you block pain receptors, opioid receptors, you unintentionally release the brake that restrains itch. Normally, pain signals inhibit itch signals in the spinal cord. But when morphine locks down pain channels, the itch pathway becomes unlocked. its signals amplified and spread across the central nervous system. This clearly shows that itch is not less pain. But what emerges when pain is absent? A biological imbalance between two electrical circuits. Worse still, when you scratch, the body releases serotonin, a neurotransmitter often labeled the happiness chemical. But in this biochemical illusion, serotonin activates 5-HT1A receptors on sensory neurons, making them even more sensitive to itch stimulation. The result is an entropy loop. You scratch to reduce discomfort. Yet the act creates the conditions for the itch to intensify. The brain thinks it is fixing an error, but it is actually amplifying it, like a security system that increases sensor sensitivity after every false alarm, until even a breeze triggers a siren. Itch is proof that the human body was not designed for happiness, but for survival. In this biological system, discomfort is the message, and pleasure is only a brief reward that sustains survival behavior. Every scratch is a contract. You accept a little pain in exchange for a moment of control. But look deeper, and it becomes a reminder that every natural instinct is built from evolutionary contradictions. An itch is not simply a flaw in the body. It is the final warning song that life sends you. Pay attention. Something is touching your border.